Okay, this is Investigation 12A and 12B, and it's actually about hurricanes. We did a little bit about hurricanes yesterday while we learned how to go through the National Hurricane Center site, find some things that we wanted to look at, a lot of the hurricane cyclone advisories, things like that. Okay, so I'm going to kind of hop around, skip around, so I'm not going to read absolutely everything. So you need to make sure that you're paying attention and that you are listening and following along, because you won't necessarily see me marking answers, but I'm going to walk you through this. So if you will listen, you should be just fine. So to introduce everything, the 2005 hurricane season in the Atlantic Basin, which includes the Caribbean and the Gulf of Mexico, was a record breaker. In terms of the number of tropical cyclones, there were 27 named storms. That's both tropical storms and hurricanes, compared to the long-term average of about 10 and the previous record of 21 in 1933. 15 of the tropical cyclones reached hurricane intensity, which is 9 above the average. And 7 of the hurricanes were major systems, meaning Saffir-Simpson Category 3 or higher, versus an average of 3 in other years. The major story, of course, was that 4 of those hurricanes reached the maximum intensity of Category 5, and 3 made landfall along the U.S. Gulf Coast. That's Katrina, Rita, and Wilma. Responsibility for the forecasting and warning of tropical weather systems in the Atlantic and the eastern portion of the Pacific Ocean basins resides with the National Hurricane Center in Miami, Florida. We visited the National Hurricane Center's site yesterday. Okay, so I'm going to skip down. It says that site contains the latest information on tropical weather systems, as well as a wealth of historical and other information regarding hurricanes, and we looked at several things. Okay, this particular investigation involves evaluating the forecast track of an intensifying tropical cyclone that began as a tropical depression and quickly reached tropical storm strength. It formed over the southern Bahamas at the beginning of the observation period. This storm was Katrina. Katrina was an extraordinarily powerful and deadly hurricane that carved a wide swath of catastrophic damage and inflicted large loss of life. It was the costliest and one of the 5 deadliest hurricanes to ever strike the United States. All right. Figures 1, 2, and 3 are selected tropical storm advisories from the National Hurricane Center Katrina Graphic Archives. Remember, we looked through the graphic archives in our scavenger hunt yesterday. So today we're looking specifically at some of the images from Katrina's archives. Each figure's inset legend shows information including the stage of development, date and time, along with the sequential number of the advisory issued. You should have some familiarity with those because we looked at them yesterday. Okay? And color coding shows coastal and land areas where watches or warnings have been issued, as described in Table 1. Okay, so yellow, tropical storm watch. Blue, tropical storm warning. Pink, hurricane watch. Red, hurricane warning. The center of the circulation at the time was plotted in each figure with a dot in orange. Additionally, large black dots display the forecast position centers with times showing expected tropical storm, S, or hurricane strength, H, and the white cone of forecast uncertainty in future positions. We will examine 3 advisories issued by the National Hurricane Center as it tracked the storm that became Hurricane Katrina and impacted southern Florida and then went on to devastate so much of the Gulf Coast. All right, Figure 1 is coming up. Figure 1 is the first advisory issued by the National Hurricane Center when this tropical system reached enough strength and potential to merit attention. The advisory was communicated to emergency managers and the public at 5 p.m. Eastern Daylight Time on the 23rd of August, 2005. As described in the inset legend, the center of the system's circulation was located over the southern Bahamas at that time. The maximum sustained wind speed was determined to be 35 miles per hour, and the system was moving toward the northeast. northwest at 8 miles an hour. All right, so here is figure 1. Okay, here's our box. 5 p.m. Eastern Daylight Time, Tuesday, the 23rd of August, 2005. It's located at 23.2 degrees north and 75.5 degrees west, maximum sustained winds of 35 miles an hour. And currently, when this advisory was made, it was moving northwest at 8 miles an hour. Okay. So I still have the advisory picture up, but now I'm looking at the questions on the paper below the advisory. So you're going to have to listen and pay attention and follow along. Question number 1, it says, at 5 p.m. Eastern Daylight Time on Tuesday, the 23rd of August, the status of this tropical weather system as described in the figure legend was a tropical depression, tropical storm, or hurricane. You need to circle the appropriate answer. Remember, you can go back and use the Saffir-Simpson wind scale to figure out which one of those 3 you should circle, okay? Because the maximum sustained winds for this advisory is 35 miles an hour. Number 2, the forecast path showed that the system was expected to travel generally northwestward through the Bahamas and make landfall on the Florida coast at the northern edge of the Miami metropolitan area at about midnight on Thursday. At the time of landfall in Florida, the system was expected to be tropical depression, tropical storm, or hurricane. Well, if you look, here's the current position as of this advisory, advisory number 1. It will later become S for storm, S for storm, S for storm, S for storm, S for storm. So when it hits and makes landfall, what is it? Well, it's an S here and an S here, so it should be a tropical storm when it makes landfall. Now, that's according to this first advisory. And remember that things can always change, and that's why they frequently update these advisories. But that should help you answer question number 2. Question number 3. Note that there are no colored shadings indicating watches or warnings shown along the Florida coastline. This time of predicted landfall on the Florida coast was about 55 hours beyond the advisory time. The definition of watches and warnings given in Table 1 indicate that there could or could not be, or could not have been, a watch or warning posted for this area at 5 p.m. on Tuesday. Okay, so if we go back, it says you're going to have yellow if you're going to have tropical storm conditions possible within 36 hours. Blue, tropical storm warning within 24 hours. Pink, hurricane watch if those conditions will come within 36 hours. Hurricane warning if it's within 24 hours. Okay? But if you go back to question 3, the definitions of watches and warnings given in Table 1 indicate that there could or could not have been a watch or warning. Remember, this is 55 hours beyond the advisory time, and we just looked at the watches and warnings, and we're not going to post a watch or a warning more than 36 hours out, okay? And we're 55 hours out, so obviously we're not going to put any warnings out for Florida. Okay, you do have some blue marks because there are some tropical storm warnings in the Bahamas, but that's not what number 3 is asking about. The item on number 3 is asking about the Florida coastline, and there are no watches or warnings posted on the Florida coastline. All right, I'm now looking at question number 4. If you lived in the threatened region of South Florida and knew of the counterclockwise circulation of the advancing storm as seen from above, like if you were looking at it from space, you should expect the highest storm surge to occur to the, south or north of the point of the center's landfall. Okay, I'm going to show you a simulation that's going to help you figure this out. So landfall is predicted to be right here, and they're asking, is storm surge going to be worse up here or down here, to the north or to the south? We're going to go look. Now, this is actually Harvey from last year, but it's going to show you the same sort of issue. If you look at the circulation, when I play this, you notice that it's rotating this way, counterclockwise. So all of this out here, all of these rain bands are over the Gulf of Mexico, picking up lots of water and turning this way, which means that the storm surge on this side of the storm is going to be more severe than the storm surge on this side, because here it's coming from over the water. Oops. Okay, oops, going to play it again. All right, so here it's spinning from over the water, and on the south side, it's coming from over the land. So you're not going to have as much storm surge to the south as you will to the north. And it's going to be the same case pretty much for any hurricane that hits like that because of its counterclockwise spinning. All right, so number 4, we've just talked about, should the storm surge occur to the south or to the north of the center's landfall? So circle your answer. Number 5, while the heavy black line is the forecaster's most probable track of the center of the storm circulation, the National Hurricane Center forecast models indicated a distinct probability that the center may pass elsewhere when the cone is displayed in decreasing probability to either side away from the center track. This white cone of potential track location shows that in 3 days, meaning at 2 p.m. Friday, the center might possibly be located somewhere between northern Florida and northern Cuba, okay? Not all the way to Georgia, okay? Georgia's way up here, okay? And not all the way down to the Yucatan Peninsula, because that's way over here, okay? So circle the appropriate answer for that one also. Okay, I'm going to stop this screencast now because we're about to move on to Figure 2. So join me for the second screencast in just a minute.